So welcome to this video. In this video, we are going to discuss about risk and uncertainty in investment appraisal. This is a very important topic from the exam point of view because normally in a 20 mark, you might get a investment appraisal problem. Additionally, you might also get a theory topic. So usually that additional theory topic would be from risk and uncertainty, and it can also be tested in section A and B, which is OTQs of 2 mark. So these are the methods that we are going to discuss in the risk and uncertainty chapter. So sensitivity analysis, certainty equivalent, probability analysis, simulation, discounted payback, and risk adjusted rate of return. So what we are going to, so from the exam point of view, you are required to both know each of these methods in detail, and also you should know where it is like applicable and where this cannot be like applied. So you should know the pros and cons of each of these methods. So first what we'll do is we'll discuss what is risk and what is uncertainty. So risk and uncertainty are used interchangeably, but they are actually very different. Risk refers to those situations whose outcome can be predicted with some accuracy. So risk is measured through standard deviation, probability analysis, and also with other tools also. This is possible because there are past data where similar events have occurred and we have data about these events. Okay, so things have happened in the past which are like similar to the things which we are deciding about. So what happens is we can take the previous data and information about the event and we assume that the same thing can happen in the future. So we can measure risk because we assume the same situations are going to be repeated in the future, which have already occurred in the past. So as it has occurred in the past, we have data about how the event has panned out. So we take those probabilities, those situations, and we try to forecast them. Okay, so that is what we do in risk. But in uncertainty, refers to those situations whose outcome cannot be predicted. So you cannot predict what will happen in the future. So the only tool that we have to predict uncertainties is scenario analysis. This is because there is no past data. So it is such a unique thing that we don't have a past data at all. So that is the problem with the uncertainty. So we can say like this, risk is something like the season. Okay, so seasons keep on like repeating. So in the last summer season, if we have sold 100 crores of goods in this summer also we will be like selling 100 crores of goods. Okay, but uncertainty is not like that. It's not like the season. It's something like a tsunami. Okay, where we can never predict when it will occur and we don't know like what would be the scale of its destruction. So best what we can do is we can only create a scenario. Okay, so risk is something like season which occurs in a repeated manner, but uncertainty is something which is a unpredictable thing. So it is something like a tsunami. So assume that you have performed an NPV analysis and you have got an answer that it is a positive number and you feel that you have to accept the project. Okay, but there is a question here. If it's like positive, does it mean that it doesn't have any risk at all? The answer is there is a risk element always attached. So where is the risk element like attached? See, there are like several variables that we have used in the NPV. For example, we would have used variable cost, fixed cost, sales, or volume, or investment. We have used so many variables here. So we are trying to find out for what percentage of change in variable cost will lead the NPV to 0. Okay, so if a 5% change in variable cost leads to NPV becoming 0, that is sensitivity. So what happens is we are trying to do the sensitivity on an individual basis for each and every item. So if there's a 10% change in fixed cost, then NPV becomes 0, or there's a 20% change in investment, then NPV becomes 0. Okay, so we are trying to find out on an individual basis only when variable cost change, only when fixed cost changes, only when investment amount changes. Okay, so it is only on an individual basis. So this individual basis is very important for sensitivity analysis concept. So we'll discuss about the concept in detail. It indicates which variable is the key or critical variable in an NPV. That is, the variable in which the smallest change will make the NPV to 0. Sensitivity helps management identify which variables have to be focused in order to make an investment project successful. Sensitivity is always expressed as a percentage. Sensitivity is calculated for each input individually. Sensitivity formula works like this: NPV divided by the present value of cash flow under consideration into 100. Okay, it's not about percentage, into 100. So these are the these are the important points for sensitivity analysis. So sensitivity can be calculated for each of these items on an individual basis. So the formula works like this: the numerator is always NPV, okay, except for cost of capital. The numerator is always NPV. The denominator is always the variable. So it's fixed cost, sorry, it's variable cost, fixed cost, sales, contribution, initial investment into 100. So the formula is very easy to memorize. The numerator is always the NPV. The denominator is always the variables which are here. So we'll have a discussion about sensitivity analysis. Which variable among the following is very sensitive and makes the NPV to 0? So a company has already done an NPV analysis. So you have already done an NPV analysis and you have already done a sensitivity analysis also. You have got these numbers. So the NPV will become to 0 if variable cost changes by 5%, if fixed cost changes by 20%, selling price changes by 25%, sales volume changes by 20%, initial investment changes by 2%, and cost of capital changes by 50%. So which of these numbers the company has to focus, okay, in order to ensure that NPV does not become to 0? So which number they have to focus a lot? Whether you should focus on the highest number or whether you should focus on the lowest number. The answer is you have to focus on the lowest number, because even a 2% change in initial investment will make the NPV 0. Okay, but if you take cost of capital, the cost of capital has to change by 50%. Okay, changing by 50% is like very low probability. Okay, but changing by 2% is a high probability. Okay, so what happens is you have to focus on initial investment. So assume you have done the sensitivity analysis like this. So which of these variables you have to keep keenly looking at? First, you have to look at initial investment. Second is variable cost. Third is fixed cost and sales volume. So fourth would be the selling price, and fifth will be the cost of capital. So you have to be like very careful about two numbers here. One is the variable cost, because even a 5% change in variable cost will make the NPV 0, and initial investment, where a 2% change in initial investment will make the NPV 0. Okay, other numbers, if you take there like a 20%, 25% or 50%, so that kind of a change, I think it has a low chance of moving to 20%. So the company has to focus on the variable cost and initial investment. Okay, so that's about the sensitivity analysis. So now we'll move on to the certainty equivalent. In this method, the inflows are reduced and outflows are increased to accommodate the risk inherent in the cash flow. So what they do is, once you are doing a NPV, you are trying to reduce all the cash inflows and you're trying to increase all the cash outflows. Because of this, you are incorporating the risk in the project. But once certainty equivalent is used, the discount factor that you have to use is not the cost of capital. You should not use this number. You should use the risk-free rate. Okay, so it is also given as RF. Okay, so that's about the concept here. So we'll have a problem. So here what we have done is, we have given the present value of cash flow for 3 years, and every year it is the same 100. Okay. So here what we are doing is, the certainty of the cash flow to be received on the first year is 100%. The certainty of cash flow to be received on the second year is 90%. The certainty of cash flow to be received in the third year is 80%. So we multiply both these numbers and we arrive at this number. Okay. But if you look at here, the numbers of 100, we have taken them as present value of cash flow. Okay. So it means there have been like cash flow and it has been multiplied by a discount factor. The question is, what has been the discount factor? The discount factor is the RF, or the risk-free rate of return. So cash flow multiplied by the discount factor, which is the risk-free rate of return. I have got the year 1, 2, 3 cash flow. From there on, what I do is I try to decrease the cash inflows. Okay, there's no cash outflow here, so I decrease the cash inflows. So that's about certainty equivalence. So next one, we'll be like moving towards the probability analysis. So probability analysis, as the name suggests, it uses probabilities to the expected future cash flows of an investment and uses these to calculate the expected net present value. Okay, so we use probability to the NPVs and we get something called as a expected net present value. The expected net present value is the average NPV. Okay, once you use a probability, it means that you are getting an average NPV. That would be expected to occur if an investment project would be repeated in a large number of times. Okay, so where can you use probability analysis? Assume that you are going to sell magazines. Okay, you are going to sell magazines in a railway station. Okay, and you want to do an NPV to know whether it's like profitable to sell magazines in a railway station or not. See, one day the magazine will be selling higher, another day the magazine will be selling lower. So there is a variability, but it's a predictable variability, because every Monday you will be selling 100, every Tuesday you will be approximately selling some 50, every Wednesday you will be like selling something like 80 magazines. So it's not a one-off business. It is something like every week you're going to repeat the same sales of magazines here. Okay, so the probability is going to occur again and again and again, so for over a period of weeks. Okay, so for those kinds of decisions where it's repeated in a large number of times, then applying probability is the right thing. For example, if it's going to be a one-off decision, for example, they are going to construct a factory, that is a one-off decision. They are going to purchase a machine, that is a one-off decision. So for these one-off decisions, you can't apply probability analysis. Okay, so that is also a very important point. For a repeated kind of a business, probability analysis is right. For a one-off decisions, probability analysis is a wrong method. So the weakness of probability analysis lies in the difficulty of estimating the probabilities, okay, that are to be attached to the future cash flows. So somewhere we have found that there will be 80% chance of sales, but how did we arrive at this 80%? What is the validity for it? Is it an objective number or is it a subjective number? So that seems to be the problem with probability. While these probabilities can be based on expert judgment or previous experience of similar investment, there remains an element of subjectivity which cannot be escaped. So there is always some kind of a subjectivity. So we'll move on to probability analysis. So for example, imagine that an investor has a choice to accept a guaranteed 10 million cash inflows, or he has an option to invest in the following investment. So I have already done the cash flow into discount factor, so that I have done. So we have got the number 7.5 in scenario 1, 15.5 in scenario 2, and 4 in scenario 3. Okay, so the probability of scenario 1 occurring is 30%, the probability of scenario 2 occurring is 50% and the probability of scenario 3 occurring is 20%. So put together you have to always get a probability of 100% or the number 1. Okay, when you add all the probabilities together you have to get 100 or 1. So now what we do is we have to get the probable cash flow that we'll get. So multiply the cash flow into the probability, you will get the present value of cash flow into probability. Do the same thing for all the scenarios. Now add all these numbers and put them together, you will get your 10.8. Okay, so the expected net present value is 10.8. So what would you do? Whether as an investor would you choose a guaranteed 10 million or whether would you like to take risk and earn 10.8? Okay, whichever you choose, both the answers are right, but still it depends upon your risk perception. If you want to take risk, you will go with this because you get an additional 0.8 for taking the risk. If you do not want to take the risk, still you can get 10 million. So it's only up to you. So that's about the probability analysis. So we'll move on to the simulation or Monte Carlo method. Sensitivity analysis is calculated for each input individually. So that is the drawback of sensitivity analysis. But in real world, all variables will move in different direction. So it is not that variable cost alone will move by 10%. It's like all the numbers, all the variables will move in different directions. Hence, simulation method estimates what would be the expected NPV for all the different scenarios of probability. So this method, what it does, it takes all the iterations and all the movement of each variable in the NPV analysis, and it tries to tell when we consider all the movement of all the variables in the NPV analysis, what would be the average expected NPV. So it would tell you the expected NPV. The expected NPV is the long run average NPV of several iterations, hence might be suitable for a business which is repeating the same variables for a number of times. So as similar to the probability analysis where you can apply this method to selling magazine at railway station. Okay, so for that decision simulation is useful, but it is not useful in one-off decisions. You can't apply simulation or Monte Carlo method, so such as building a factory. For that you can't apply this method. Okay, so that's about the theoretical background. We look at how simulation will work. So we have come to the simulation table here. Assume that a company is having sales, variable cost and fixed cost. Okay, and the thing is, for sales they are not sure about how much amount they will get, so they feel that 40% chance that they will receive 10,000, there's a 60% chance they will receive 20,000. Okay, and again 20% chance of a variable cost of 5,000 and 80% chance for variable cost to be 8,000 and a 10% chance for fixed cost to be 4,000 and a 90% chance for fixed cost to be 2,000. Okay, so we have these numbers. So now we have to assign random numbers to this probability. So as it is a probability of 40, okay, we'll assign 1 to 40 for this. From the 41 to 60, there are 60 numbers that we'll assign to 20,000. The next one is variable cost has a probability of 20. So 1 to 20 we'll assign for this variable cost of 5,000. The next variable cost of 80%, what we'll do is we'll allocate 21 to 100. So 80 numbers are there. So in the same way, for 10% probability we'll assign 10 numbers, and for 90% probability we'll assign 90 numbers. So we have assigned numbers to each of the cash flows. Okay, so that's how it works. So now what we'll do is we'll write numbers from 1 to 100 in chips, and we will fold them and we'll put it in a box, and from that box we'll select 3 numbers. Okay, so assume that we have got the numbers 28, 84 and 5. The number 28 refers to what? the number 28 is within this classification or this classification. It is under this classification. So take that cash flow. The cash flow is 10,000. So the relevant sales is 10. 84 lies within which range? This one or this one? It lies within this range. So take this cash flow. Cash flow is 8,000. So cash flow of 8,000 will flow here. Then take the number 5. Okay. You have taken the you have picked the number 5. 5 falls within which category? It falls within this category. So take the number 4,000 and put it here. So now find out the NPV. So NPV is minus 2,000. Okay. So we'll repeat it once again so that you understand it. So again, you fold all the chits, you put it in a box. Okay. From 1 to 100 you have written, you have closed the chit, you have put it in a box. Now randomly you have taken, and when you open the chit, the numbers 96, 18 and 67 occurs. 96 is within this, so take the 20,000 and put it here. 18 is within this, so take the 5,000 and put it here. The number 67 is here, so take the number 2,000 and put it here. So now compute the NPV. So NPV comes to 13,000. Okay. So you have got 2 iterations of numbers. So now we'll see like what happens hereafter. Okay. So here what happens is you keep on doing this. Okay. You keep on picking the chits and you keep on doing it. How many times you do it? Assume that you do it for 100 times. Okay. See, as it is not possible for humans to keep on doing it, that's why we use a computer. So computer softwares are available to do this repeatedly for 100 times, and each time you will get a new NPV. You won't get the same NPV. Okay, we might even get the same NPV, but we are going to do it 100 times. Okay, how many times should we repeat? It's not that 100 is a perfect number. It depends upon how many iterations you want. You can even fix 1,000 times. Okay, it depends upon you. For our convenience, we will take it as 100 times. Okay, so we are going to do the same thing for 100 times and we'll get 100 NPVs, which might be the similar amount or it can be a different amount, but we have got all the 100 NPVs. Now what we have to do is we have to classify them in a histogram. So we'll start here. So we'll create a graph. On a graph, this axis represents the NPV, and we'll take NPVs like this. So NPVs are like in thousands we will take. So NPV of minus 10,000 to 5,000 is here, minus 5,000 to 0 is here, 0 NPVs are here, 0 to plus 5,000 NPV are here, plus 5,000 NPV to 10,000 NPV is here. So we have got the NPVs. So number of times they are occurring. So if they are occurring 10 times, 20 times, 30 times or 40 times, so we have a range of times they are occurring. For example, we have done 100 times. Okay, we have done 100 times the NPV analysis. So every time we are picking a number and we got a new NPV number. Like that, assume that we got an answer like minus 2,000 NPV. So 0 to minus 5,000 NPVs have occurred 20 times. 0 NPV has occurred 40 times. 0 to plus 5,000 NPV has occurred 20 times. Plus 5 to plus 10,000 NPVs have occurred 10 times. Okay, so now you have a graph. So what do you do with this graph? You plot a chart. So when you plot, you take the center point of each column and you draw a graph. See, this is a symmetrical curve. It's called as a bell curve. What does a bell curve indicates is, as there are equal chances of positive and negative NPV to occur, the project will be rejected. See, there's a equal chance. If you take, there's a 30% chance this will occur, right? There's a 30% chance. 10 plus 20, 30. There's again a 30% chance these things will occur. Okay, so and there's a 40% chance it will be 0. So it is like equally giving us outcomes. So what happens is, if we are going to choose this project, there's a high chance we might get a profit and we might get a loss, but there's an equal chance of getting it. So this is not such a good kind of a project, so we will reject it. So we'll do it again for some other set of numbers. Assume that our sales value changes or probability changes. If that changes, we might again work out a simulation. For example, for a changed set of sales variable cost and fixed cost and a changed probability, we might get an outcome like this. So the outcome has changed. Okay, so the negative numbers have fallen. Okay, negative NPVs have fallen. There's only a 10% chance these things will occur, and there's a 70% chance that positive things can occur, and there's only a 20% chance the NPV will be zero. So the chance of the NPV will be negative is 10%. So if you draw a curve, it will be like this. If you have a curve like this, it means there's a high chance, okay, that the project might be profitable. So as there are more chances of positive NPV, the project will be selected. So that's about the simulation. Assume we again have the numbers changed. For example, we are going to get a new set of numbers as sales, fixed cost and variable cost, and the probabilities of them occurring are also going to change. In that case, we have to again work it out. So when you again work it out for a new set of numbers, you might get a chart like this. So if you see here, there's a 70% chance, okay, of NPV being negative. There's a 70% chance of being negative, and there's a 10% chance of being positive, and a 20% chance of being zero, NPV being zero. So your plot will be like this. So if you have a plot like this, it means that as there are more chances of negative NPV, the project will be rejected. So that is about the simulation. So the best thing about simulation is it doesn't just take one variable and analyze it like how sensitivity does it. Simulation takes all the variables taking into account, and it assumes all the numbers are going to change in a random way. So even if they change in random way, so how would the profitability of a project would be affected? Okay, so that's what simulation does. Simulation is an amazing technique, but again, it only works for companies who are going to do a repeated business and not a one-off business. So in repeated decisions and not in one-off decisions, only in those situations simulation is applicable. So we'll move on to the next topic. So the next topic is discounted payback. It is a capital budgeting procedure used to determine the liquidity of a project. So how liquid a project is. A discounted payback period gives the number of years it takes to break even from undertaking the initial expenditure by discounting future cash flows and recognizing the time value of money. So the formula works like this: discounted payback, okay, the answer is always in years, equals to present value of cash outflow divided by present value of cash inflow. Okay, so if you take like 1000 is the present value of cash outflow and 500 is the present value of cash inflow, then in 2 years time you will recover the investment. Okay, so that's about it. So here discounted payback should be lower. Okay, the lower the better. For example, if the cash outflow is going to be 1000 and we are going to earn 100 rupees per year, then the payback will be like 10 years. So which is better? Lower the better. So that's how you have to select the discounted payback. So we'll move on to the next one. It's called as the risk adjusted discount rate. See, all projects do not have the same riskiness. Hence, the discount factor should be different for different projects. High risk projects should be discounted using higher discount rate, and low risk projects should be discounted using lower discount rate. But the discount rate chosen is always subjective, right? So they say that see, all projects are not going to be having same risk, so don't use the same discount factor to discount all the cash flows. If a project has a high risk, use high discount factor. If a project has a low risk, use a low discount factor. But the problem is whether you should use a high discount factor or a low discount factor. For example, if you use 20% for a high risk project and a 5% for a low risk project, how did you arrive at 20% and 5%? That is itself a question. For example, You might have taken 20% and 5%. I might have taken 22% and 4%. So, am I wrong? The answer is, as it is a subjective number, anyone can assume any number. So, that is what they tell here. The number which we choose for discount factor is a subjective number. What is the problem with this? This leads to rejecting profitable projects and accepting loss-making projects using the discount rate. Okay, if your discount rate is wrong, for example, our cost of capital of a company is 10%. At a 10%, an NPV is 100, and we have chosen the project. But suddenly we feel the project is a little bit risky, so we take 15%, and NPV, what happens is it goes to minus 50. Okay, now we will reject. See, what happens is, if you're going to have a high discount factor, there's a chance that you will reject the NPV. Okay, you will reject the project. So that is a problem if you're going to choose subjective discount factors like this. Okay, so that's what they are telling about this question, this part. For this part, you try to work it out. So we'll have quiz. Ridaco is appraising a different project with a positive NPV. It is concerned about the risk and uncertainty associated with this project. Which of the following statement about risk, uncertainty, and project is true? Which of the following is true? Sensitivity analysis takes into account the interrelationship between the project variables. No, sensitivity analysis does not do that. Probability analysis can be used to assess uncertainty. Probability is a risk measure, so it does not measure the uncertainty. So this is wrong. Uncertainty can be said to increase with project life, while risk increases with the variability of returns. Yes, this is true. Uncertainty is we don't know like what would happen in the future. So as we keep on increasing with project life, we are entering into an uncertain situation. But risk, what happens is the amount that we are going to get in each year, that is what we are not sure about. So that increases the variability. Okay, so risk in the cash flow increases with the variability of return. So for example, if the variability of return is 50%, then the risk is 50%. If the variability of returns is 10%, then the risk is 10%. So this is right. D, a discount rate of 5% could be used to lessen the effect of later cash flows on the decision. This statement doesn't seem to be quite right at all. So we'll mark it as wrong. So we'll see the answer. The answer is C. So we have another quiz. Which of the following statements are correct? The sensitivity analysis of a project variable can be calculated by dividing the project NPV by the present value of the cash flows relating to that project variable. Is it right? Yes, that is the formula. NPV divided by the present value of that variable into 100 has to be there, but that's not given the question, but still it's right. The expected NPV, I think this is the probability, is the value expected to occur if an investment project with several possible outcomes is undertaken once. No, it's undertaken many times. Okay, once means it's a one-off decision. Many times refers to repeated decisions. So this is wrong. The discounted payback period is the time taken for the cumulative net present value to change from negative to positive. The answer is yes. The negative to positive is called as the break-even point. Then the break-even point. So this is right. So the answer should be 1 and 3 are correct. So the answer should be B. The answer is B. So we look at what are the questions which have come in the past exams. This topic has been like asked on a regular basis. If you see here in June 18, June 17, again in June 17, June 16, these questions have occurred. So just go through these questions. You will have an idea like what type of questions are like repeating. Also, you have questions like these which have occurred in June 15, June 12, December 11, and June 11. So this is a fairly repeated area for theory questions. So thank you very much for watching the video. We'll meet in the next video.